I do believe I'd have to be teleprompted what to say if I did this every day. That's the thing with doing these flow projects, though, we learn things all the time. And what I would like to have, I'd like to have a program that types down what I say, because whenever I do these, I really, most of the time, I don't know what I want to say until I try to do it. And so it can sit there and be working out what I need to be teleprompted to say. Okay, we got on the old circuit, we had the 4017, and I was wanting to do with the Night Rider chaser light, so you got going one way and coming back the other way. The 4017, you can do that, but it's only 8 bits, so we can only do it with 5 lights. So, because we have to tell it to go one way, and then the extra light, you only tell it once, and tell it to go on the way back. So we can only use 4 outputs if we do it down and back. And when we're going using down and back, we have to have LEDs on the outputs before the LEDs, so that way the LEDs have less impedance and it doesn't backfeed through the other outputs. So I did learn that. So that's another thing we learned. And also on these 74LS 373s and 374s, I learned some things. And if I was engineering for component level engineering, I would need to know these parts better. I was thinking about putting, or forgot to put pull-ups, and actually on these components it says you might be able to use it without having to pull-up components. So I'll read that real quick. These 8-bit registers feature 3-state outputs designed specifically for driving high-level capacity or relatively low impedance loads. These high impedance, 3-state, and increased high logic level drive provide these registers with the capability of being connected directly to and driving the bus lines in a bus organized system without the need for interference of pull-up components. These devices are particularly attractive for implementing buffer registers, I/O ports, bidirectional bus drivers, and working registers. I did have some 74LS 373s, and I try to use them. The problem with the 373s, they are just looking for a high or a low on the clock pulse. So they can sit there and run the whole register within one pulse. So you can barely see it blink. On the 74s, they don't trigger until you get the edge of a clock pulse. So you can actually see each individual clock pulse being displayed in the outputs, which that's real nice. It's real handy. Okay, alrighty. So we'll go ahead and get that hooked up and watch it work. Okay, right now they're all on, which means I got them syncing because it worked better in this circuit. I think maybe that they were designed for a low input. So my the highs on the LEDs are all connected on this side. So I'll go ahead and hit the reset. The reset's going to set them all high, and now they're set all off. And I can give it a pulse, and that will start the low register. That'll sync one output. So we synced one output. You can see it's driving one way, then coming right back. Okay, I can change my clock speed like I did on the other one. And she goes faster. Okay, I'll go ahead and reset it again. And now I want to go ahead and just wait just a little bit longer, and I can send different low signals at different times on the clock pulse. That's kind of cool. I'll speed it up and do the same thing. Alright, that's kind of, it's easier to set it up on the slow speed. And we can set it up and watch it run. Okay, I'm having fun. Here we go.